Consider a solid sphere, a solid cylinder, and a hollow cylinder having same masses are rolled on a ramp. Which one will reach the bottom first? Let us check. Sphere reaches the bottom first. Do you know why? To know this reason, you have to understand what is moment of inertia. Let us learn about moment of inertia. Here there are two wheels with same mass and different radius. If they are made to rotate on the road, which one is hard to rotate? The radius of wheel A is greater than the radius of wheel B. Wheel B accelerates faster than wheel A. Since wheel A has more radius, the mass distributed about the center of the wheel A is greater than that of the wheel B. So, moment of inertia of A is greater than moment of inertia of B. Moment of inertia is a scalar value which tells us how difficult it is to change the rotational velocity of the object around a given rotational axis. If moment of inertia is relatively large, it is very difficult to accelerate in angular direction. If the moment of inertia is small, it is relatively easy to rotate angularly. Therefore, with less moment of inertia, accelerate faster. Now, let us check how moment of inertia changes with respect to some physical quantities. First, we can check what happens to the moment of inertia if mass of the body changes with respect to an axis. Consider a wheel of mass 20 kg with radius 0.2 meter. Formula to find out the moment of inertia is different for different shapes and different axes. Here, the moment of inertia of the wheel about the axis of rotation is mr square, which is equal to 20 into 0.2 square, which is equal to 0.8 kg meter square. Hence, the moment of inertia about an axis through the center in this case is 0.8 kg meter square. Let us take another wheel of mass 25 kg with same radius 0.2 meter. The moment of inertia of the wheel about the axis of rotation is again mr square, which is equal to 25 into 0.2 square equal to 1 kg meter square. Therefore, the moment of inertia about the axis through the center in this case is 1 kg meter square. If the mass increases, the moment of inertia also increases. So, it is much harder to rotate an object of greater mass with same radius. Now, consider two wheels with the same mass and different radius. One wheel with mass 20 kg and radius 0.2 meter. We already calculate the moment of inertia about its axis, which is equal to 0.8 kg meter square. Now, let us take the second wheel, which has the same mass 20 kg and radius 0.5 meter. The moment of inertia of the wheel about the axis of rotation is mr square, which is equal to 20 into 0.5 square, which is equal to 5 kg meter square. Therefore, moment of inertia about the axis through the center in this case is 5 kg meter square. If the radius increases, the moment of inertia also increases. So, it is much harder to rotate an object with same mass and greater radius. Now, let us try what happens to the moment of inertia if the axis of the rotation changes. This is a rod of length L. If you grab the rod in the middle and try to spin it, it is easy to spin. Mass of the rod is distributed equally from the center of rotation. If we grab the rod at the end and try to spin it, it is extremely difficult to rotate. If the rod is rotated about an axis through the center of the rod, The formula to calculate moment of inertia about the axis through the center of the rod is ml square by 12. If the rod is rotated about an axis through an end, all the mass is distributed very far from the axis of rotation. The formula to calculate the moment of inertia about an axis through an end is ml square by 3. ml square by 3 is greater than ml square by 12 for a given rod. Therefore, moment of inertia of a spinning rod about an axis through an end of the rod is greater than moment of inertia of a rod spinning about an axis through the center of the rod. So, it is extremely difficult to rotate through an axis in which mass is distributed very far from the axis of rotation. Comparing these three examples, we can come to a conclusion that moment of inertia depends on mass of the object, radius of the object, and axis of rotation. And each shape has different formula to calculate moment of inertia. Moment of inertia is a property of any object which can be rotated. It is a scalar value which tells us how difficult it is to change the rotational velocity of the object around a given rotational axis. The moment of inertia of an object depends on mass. It also depends on the distribution of mass related to the axis of rotation. Now, if you look into our initial problem, the moment of inertia of a solid sphere about its central axis is 2 by 5 mr square. Moment of inertia of a solid cylinder about its central axis is half mr square. The moment of inertia of a hollow cylinder about its central axis is mr square. If mass is same in three cases, mr square is greater than half mr square is greater than 2 by 5 mr square. Sphere has lesser moment of inertia among these three, so it reaches the bottom first.